Hi, I wanted to show you a little project that I did when I was learning to laser cut. I made a kind of jigsaw puzzle, but I mean technically not a jigsaw puzzle because I didn't make it with a jigsaw, I made it with a laser cutter. But what I did is I created a kind of jigsaw puzzle-like thing that actually converts between decimal and binary, converts decimal numbers into binary numbers by just solving the puzzle. So I want to show you that. First thing we need to do is pick a number, a two-digit decimal number. So what do you think? Okay, 42, that's a good choice. Kind of predictable, but nonetheless, I think we can work with it. So what we have to do is we need to take a 4-piece and a 2-piece and link them together. So I've got 10 different pieces that kind of have this basic shape that are the tens digit, and I've got 10 different digits that are this kind of units place. And when you click them together like this, you get a little puzzle inside, right? You see this little empty space here. And we can fill that with these red pieces, however it works. So let's try to fill in the little puzzle that's created by these two green pieces. So let's see. No, that doesn't fit. Oh, there we go. All right. Oh, that works. Or does it? Haha. Nope. It's upside down. Sorry. Oh, there we go. Okay, we got it. Nailed it. All right. Perfect. Okay, so I claim that this is the only way to fill in the inside of the green piece puzzle with red pieces. And if we now look at the binary representation, or the binary sequence that we got there, it should be exactly 42. So 1, 2, 4, 8, 16, 32, plus 8 is 40, plus 2 is 42. Ta-da! It's kind of like a magic trick. All right, so now, like any, I guess, bad magician, I was going to say good magician, I'm going to show you how the trick is done. Let's pick another pair. We'll make it 56. And so this is how we do it. What the puzzle actually is doing is it's adding the binary representations of 50 and 6 together using these puzzle pieces. So how does it do that? Well, the 6 is the binary representation of the 6 is encoded in the positions of the little dots along the bottom, and the binary representation of 50 is encoded by the little dots up along the top. So how is it doing that? Well, 6 can be represented in binary, or is represented in binary, as 4 plus 2. And what you can see down here at the bottom is the way the pieces fit. So if you look at the width of the different pieces, I put the blip on the right side if it represents a 0 bit, and on the left side if it represents a 1 bit. So you can see this first thing is a 0, it's on the right. Next one is a 1, this one's a 1, and all the rest of them are zeros. So 0, 0, 0, 0, 1, 1, 0 is exactly 6 in binary. And what about 50? Well, 50 is made up of 32 plus 16 is 48 plus 2 plus 0, right? So if you look at the 50, it's made up of a 0, a 1, a 0, a 0, a 1, a 1, and a 0. So 1, 1, 0, 0, 1, 0. So we've got 32 plus 16 plus 2, which is 50. And you notice a cute thing that I did here is the 0 that's associated with this 50 is not actually on the same piece as the 50. So how did we know to do that? Well, all of the tens digits, 10, 20, 30, 40, 50, 60, 70, 80, 90, they're all divisible by 2. So the bottom bit of all these things is always a 0. So I could just put it as part of the ones piece because we knew that it wouldn't change from tens piece to other tens piece. Okay, so with that set up, with the problem set up, the last little thing to know, the last little bit to know is that the position of this little blip is telling us about the carry bit. So this little pattern right here is, this is saying that we're contributing 0 from the tens place, 0 from the ones place and 0 carry. 0 plus 0 plus 0 is 0 in binary. And so one of our 0 pieces ought to fit exactly into that hole. And it should propagate a 0 carry. And that's the piece that does that. It fits right in there. It has a 0 on it. And it has a little blip here saying that we have a 0 carry. All right, so the next thing we need to do is, again, we're adding 0 and 0 with a 0 carry. So that same piece should fit again. We've got it right here. No, we don't. See, it's good when the puzzle's a little smarter than you are. Oh, right, because these are both 1s. So this is actually 1 plus a 0 carry, which is 0 carry the 1, because it's 2 in binary. So the piece that should be here is a 0, but it should have a 1 carry. And in fact, that's exactly one of the pieces that we have. It says a 0 on it, and it has a 1 for our carry bit. The next piece is now adding a 0, a 1 with a 1 carry. That's also 0 with a 1 carry, but it is a different shape than the other one because the 1s were in different places. And in fact, we have a piece that does that. All right, so now what have we got? Now we've got 0 plus 0 with the 1 carry, which is 1 with a 0 carry. So one of our 1 pieces should fit exactly into that slot. Nope, it's not that. It's not that. Here it is. Boom, right into place. So you can see that there's going to be 8 different of these red puzzle pieces. 4 that have 1s on them and 4 that have 0s on them, based on exactly the pattern of kind of these input bits. All right, what's the next thing we've got? That's a 1 and a 0 with a 0 carry, so that should be 1 with a 0 carry. Here it is now. All right, now we've got 1 plus 0, which is again 1 with a 0 carry. And finally, that's 0, 0 with a 0 carry. So the top bit's going to be a 0. But which 0? This one. And there we go. All right, so is this 56 written out in binary? 1, 2, 4, 8, 16, 32 plus 16 plus 8 is 56. Magic revealed.